In this video, we are going to install Packet Tracer. Official downloads are for Ubuntu, Windows and macOS. We will use Ubuntu. Packet Tracer is a cross-platform visual simulation tool designed by Cisco to create and practice various network topologies. We enter the NetAcad website to access the tool. Any free course from the Cisco Academy can be assigned to your account. We enter the direct link and it indicates that we must log in. We enter with our credentials. Remember to register earlier. When entering the site, it will give access to download the desired version. In this case, we use Ubuntu. We wait for download. The installer launcher will start, but it is better to install manually. We search for the file in Downloads with App Center. We click on Install. It will ask for installation authorization and password. We wait for the installation process to end. Now we look for installed files. We try in bin, but it is not there. Then we try in opt and see pt folder. So we enter it. Since a launch was not created automatically, we create it manually from the terminal using Nano in local share applications. We enter the data mainly from the app image, such as the name, the executable, the icon, and in type we set it as application. We go online to search for a Packet Tracer icon and download it to place in app. We save the launcher file and we exit. Now, in the terminal, we will install the GIMP package to save it with an adequate extension. We open GIMP and edit image. Now we must log out so that the changes take effect upon entering. We go to the applications and execute Packet Tracer. But it did not run. So we enter the terminal to run it manually. We enter opt and pt, then we execute the app image file. Packet Tracer needs the EULA license to be accepted. We do it by pressing option 2 and it asks about the multi-user mode. Now we can execute from our launcher. We execute it and enter Packet Tracer. We log in and enter from the web page itself. We check the menu searching for configuration. We found it and increased font size so that application looks much better. The first example is the connection between two computers. If no device is used, they must be connected using a crossover. We maximize the window. We select the end devices from component box, select PC and add two computers to the workspace area. Now we select connections and then crossover copper cable. We select one PC and its port, then the other PC in same way. Then we click on one PC and select desktop, then in IP configuration and enter the IP address ending with number 1 value. In the same way, we select the other PC and assign the IP ending with number 2. Same network 192.168.0 and mask 24. To test connectivity, we click on a PC, then desktop and command prompt. We ping the other PC and it successfully connects. In the same way, we must verify connectivity back. We move to the other PC and ping the first one. Everything is working fine. Once connectivity test is finished, we save our topology with an adequate name. We can reuse them in many other examples. In example number 2, we will connect two computers using a simple switch. Using straight cable, crossover is not used. We select the delete option from top bar and remove the cable. Then we add the switch. It can be the PT switch model type. Now we select connections and straight cable. We select the PC, its port, and then on switch. The same for the other PC. We make sure that IPs are configured correctly on each PC, on PC 0 ending with 1 and on PC 1 ending with number 2. When finishing configuration, we open command prompt of PC 0. We ping towards PC 1. We see that it pings correctly. Then we ping from PC1 to PC0 and verify that connectivity is correct. Then we save our network topology file now. In example number 3, we use topology from example 2, except we add a laptop, in addition to testing different networks. We add a laptop from end devices, then we make connection to the switch, just as we have done in previous video examples. On purpose, we change laptop to network 192.168.2.0 orange link. To get connection, laptop must have same network 192.168.1.0, host 3. We test the ping from PC0 to the laptop, and we can observe that now there is connectivity. Ping works correctly today. In example 4, it is same definition of example 3, with the difference that instead of different networks, different masks. To start, we change laptop host to number 150. Then we test ping from a PC and see that everything is fine. We change in all 3 end devices to mask /25. In packet tracer, we must change last 0 to 128. When pinging laptop that ends with 125, we see it no longer connects because on another subnet save file. In example 5, we will see how ARP table is populated using command of same name. Each PC has its own table in cache memory. We ping host 2 and 3 from host 1. We see the result of command ARP A, which shows known host number 2 and 3. We move to PC1 with host 2, and we see that it only has host 1 in cache. Likewise, laptop with host 3 only has 1. If from laptop or host 3, we ping host 2, we will see that table now has hosts 1 and 2, which are PC0 and PC1. If we move to PC1 with host 2 running ARP, as shows it has hosts 1 and 3, then we save our topology file properly. We exit full screen mode, and packet tracer we can observe in folder home PT saves that our saved files are located there. This has been all for this video. If you liked it, subscribe, leave a like and activate notifications. See you in the next video.